on derivatives. Okay, so implicit differentiation. None of the rules have changed. Chain rule is still chain rule, product rule is still product rule, quotient rule, all the things. Trig is still the same, LME, all those rules still exist. They are not any different. Implicit differentiation is used when y is not in terms of x. When y is not in terms of x. And what I mean by that is, typically we have a y equals or an f of x equals, and then all of your x terms. This is when that is not the case. Basically, if it looks like a big jumbled mess of x's and y's all like mixed up together. Do you get what I'm saying? And the other pep talk I give with this is, if your problem looks like a mess, your answer is probably gonna look like a mess. So if you get a big old mess, you probably did it right. Just don't get upset if your answer isn't pretty. Okay, it's gonna look like a mess, and we've got to be good on our algebra skills for this. And the other thing I'm going to say before we just like start, this is cut and dry. I'm just here to do some problems. The other thing that we need to remember is we need a chain rule for y, for our variable y. So anytime you do a derivative involving a y, you will chain rule on, you'll put a little chain rule on dy dx. That means derivative of y with respect to x. Why don't we do it for x? Well, what is the derivative of just plain x? 1. You can write times 1 all over the place if you want to, but it's going to get really cluttered. So I recommend against it. Only other thing I'll say before we just start chugging through some problems, I usually get asked, instead of dy dx, can I write y prime? You can, but I highly recommend against it because it's going to be so jumbled together that your y prime is going to get mixed in with all your y's, and you're going to have trouble, telling the difference between them. However, if you feel really strongly about it, I'm not going to have an argument with you. Go ahead and do that. Just be really, really careful.
Why do we chain rule the variable?
Because in essence, we want it to be y in terms of x. It just isn't. But if it was y in terms of x, it would be dy dx. It's just instead of dy dx equals, here, I'm saying it in words, but it'll make more sense if I write it to you. Yeah, hold on 1 second. Usually, give me a function, make something up. Let's
3x squared.
3x squared plus 17. Okay, cool. So say you have that. When you get your derivative, you can either write y prime equals, or you can write dy dx equals. I'm saying we should use this. It's just instead of doing dy dx equals blah, 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 it's going to be all mixed in together. So you're going to have sometimes multiple dy dx's spread throughout the thing. But you've been doing it all along. The derivative of y is dy dx. It's just instead of being alone by itself on the left-hand side of the equal sign, it's going to be all mixed in through. Yes, you'd have a 2 in front of it. Yeah, exactly. Did you even have a 2? Okay, never mind. Sorry. Here we go. One term at a time. Just take it easy. All right. Derivative of 3x squared. So you see, you've been doing this. Nothing's different. Okay. Minus. Now there's a y in there. Derivative of 2y squared is going to be 4y and dy dx. You chain on. You can put the little dot if you want. I usually don't for these, but it's personal preference. You chain on dy dx. Right. Equals, and then derivative of just x, 1. There ends the calculus. We're done with the calculus. From here on out, it's algebra. And I will be real honest with you. Algebra is where everyone makes their mistakes. Okay, so just be really careful. We want to get dy dx alone. So the first thing would be, okay, so here's my thing that I always tell everybody. Copy errors are where all the mistakes happen. So the less writing you do, the better off you are. So you kind of want to be a little lazy because the more copying you do, the more likely it is you're going to make a mistake. So here's what I would do. I would scratch that out and just write minus 6x. And you can even cover it up with your hand and be like, okay, that's gone now. What would your last step be to get dy dx all alone? Not subtract. Divide. Okay, so it's going to be 1 minus 6x divided by negative 4y. And if it looks like a mess, you probably did it right. Yay. I made number 2 piggyback off of number 1. It says write the What things do you need for an equation? A point and a slope. All right, let's set it up blank. Kind of make a scavenger hunt. Point and slope. So we want it to be 1 comma something. Oh, and it says for number 6. So I have a bad habit of redoing my notes and then forgetting to renumber things. I meant number 1. I'm really sorry. That won't be the last time that happens. I have a bad habit of doing that and forgetting to renumber my problems. So I apologize. That's my bad. I meant number 1. How would we get our y value? What are we going to do with x equals 1? Plug it in where?
To the first equation.
To the original, to x. Whoever said x, you're correct. We're going to plug it into x in the first equation and then do some algebra. All right, I'm just going to write this off to the side. This is like a margin problem. 1 squared is 1 times 3 is 3 minus 2y squared equals 1. We're plugging in 1 for x. All right, here comes the algebra. Now what? Welcome back to Algebra 2 class. That's where you would do something like this. Subtract 3. Perfect. 1 minus 3, negative 2. Good. That cancels or divides out. Can I say cancels? I don't know. Whatever. Either way, that's going to be 1. Okay. I'm gonna say cancels out. All right, and then square root. Now you get y equals 1, but you also get negative 1s, plus and minus. Okay, so we are actually going to get 2 answers to this. I'm going to set up another scavenger hunt. And there's going to be 2 answers. So one of them is going to be 1 comma 1. They're going to be practically the same answer, right? And the other one is going to be 1 comma negative 1. Cool, we made it through then, and no one lost their mind over there being 2 answers, so that's good. All right, slope comes from derivative, which we found right here, okay? So for this first one, we're going to plug 1 in for x and 1 in for y and see what we get. That would give us, what would that be, negative 5 over negative 4, which would be 5/4. All right, and then the other one, we're going to plug 1 in for x and negative 1 in for y. So that would be negative 5 over positive 4. I told you they were going to be practically the same answer. It's almost the exact same thing. Wait, did I lose somebody? Where did I get what? Or you're explaining that. That's fine. Go ahead. So let me draw a picture of that as well. And it's not going to match this exactly. I'm just going to make something up because I don't know what this would look like. But for example, you can have, I'm trying to think how I want to draw it. I'm not a great artist, so something like that.
But it's not x, isn't it? There are 2 y values at x.
Yeah, okay, so I would need it to go this way. Yeah, see, I'm trying to visualize it. Hold on a second. I'm using my imagination.
Circle.
Yeah, okay, cool. I'll do a circle. Good call. Thank you. So it's not a function. It's not going to pass the vertical line test. So say you had a circle. You're going to have one tangent line here that's like this. And then at the same x value, so down here, you're going to have another tangent line that does this. So you get 2 tangent lines of the same graph. Is that like the visual help?
Hey, I didn't know the 2 answers.
There's 2. Yeah, you know what? I'll take that. That's good enough. But you end up with something that's not. Do you guys understand function vertical line test? Like we've left that. These aren't functions. They're a jumbled mess. They aren't going to necessarily pass a vertical line test. I love that you're asking the deeper questions, but it is hard to visualize. So don't think about it too hard. Okay. Let's write the answers. This first one, it would be y minus 1 good equals. Yep, 5/4 parentheses x minus 1. So that's one answer. And then the other one is going to be practically the same thing, but different negative signs. So it's going to be y, yeah, because it's minus negative 1, so plus 1. Oops, sorry, I bumped that. Equals negative 5/4 parentheses x minus 1. The 1 part is still the same because that was, yeah, that was given in the problem. Negative signs are the most commonly missed thing in any math class up through as far advanced as you want to get. Negative signs are always the worst. All right. Okay, let's try another one. Derivative of 5y would be 5 dy dx. Okay, good. You guys are on top of that. Now, what rule do you need for that next part? Product rule, and it's going to be a chain rule. All right, so product rule is the first thing, so x, derivative of the second, so derivative of y is dy dx. You already know this. Plus the second thing, y, and then derivative of the first. Derivative of x would just be 1. I'm going to go ahead and write that because I'm doing the problem in front of a whole group of people that I'm trying to explain it to. If you don't want to put the 1, that's fine. Equals, and then derivative of x squared is 2x. Now, when you go to do the algebra for this one, do you see how there are 2 dy dx's in there? Okay, we're going to factor. We're going to leave those where they are. I want to move this to the other side. So how would I do that? Good. And this, I think, is the easiest way to do that. Just scribble it out and put minus y. Now we're going to factor dy dx out. It's a GCF. So if you factor that out or undistribute, you'd be left with 5 plus x, good, equals the rest of this. Perfect, and then you would divide. See, and a lot of you are saying it faster than I can even write it. So your final answer will be 2x minus y over 5 plus x. Perfect. This is going well. You guys have got this. You do remember this from last year. It's going awesome. Okay, I'll get you through it. We're gonna make it. It's fine. Okay, well then I'm gonna speed this part up so we can spend more time on that. Okay, derivative of sine, cosine. So you got cosine 4x squared. Good. You have to chain rule on an 8x at this level, and at this point, because we already got through the unit on derivatives, instead of putting a dot and then 8x, I'm gonna put my 8x right here. You guys can handle it, okay? All right, minus derivative of cosine negative sine. Okay, so the negatives are going to cancel. It's going to be plus. I'm going to leave a little gap because I'm going to do the same thing I just did and put this out front of sine. All right, so sine of 5y. And then you have to chain on, but I'm going to put it in the coefficient spot. Derivative of 5y would be 5 dy dx. Perfect. Oh my gosh, awesome. The most common mistake is people will write equals 9, and in multiple choice, they will always make that one of the wrong answers. But the derivative of a constant is 0. Okay, so just be really careful. All right, now we have to get dy dx by itself. This, believe it or not, this is only 2 terms. This is all one term, and this is all the other terms. So I'm going to leave this one where it is. I want to subtract all of this to the other side. All right, so it's going to be minus 8x cosine blah, blah, blah. I'm going to scribble that out. And then your final answer will be dy dx equals negative 8x cosine 4x squared divided by what? 5 sine 5y. So just everything that's not a dy dx, because you want to get that by itself. There's a lot of stickiness with you guys. Okay, cool. There's only 3 more. We'll do these 3. We'll do a quick brain break, and then I'm just going to introduce related rates. We'll do more on it next time. I'm trying to like split that into 2 because it's a more difficult topic. Well,
take on notation. And whatever the other ones.
hold on. Let me answer this question. Go ahead.
So I know for 5y, it wouldn't become a y, like you wouldn't dump like the coefficient or.
No, the coefficient can never get combined with what's inside the trig function. Those have to stay separate.
I mean, like you're only thinking of 5y.
No, the derivative of 5y is 5 dy dx. Because you have to chain on that derivative of y, which is dy dx. All right, this one has e.
And the y.
No, nothing disappeared. What do you, hold on. Rephrase your question. No, for example, and everyone should be listening to this conversation. What's the derivative of 5x? 5. So the derivative of 5y is 5, but then you need a d. Did we communicate now? Okay, cool. Okay, derivative of 5e to the y is 5e to the y dy dx. Okay.
Can you just put that up? Would it make a difference?
Well, it's personal preference at that point. That's up to you. Yeah, sure, go for it. Go ahead. Correct. We're chaining on the derivative of what's in the exponent. It's kind of like if you had, give me some numbers or something. Let's see.
2.
E to the 2x squared plus 3x. Your derivative of that would be e to all of that stuff, and then you would chain on 4x plus 3. But do you see how that 4x plus 3 is not in the exponent? Same concept. Yeah, so it's not in the exponent, it's just chained on. You guys ask such good questions. All right, plus derivative of 3x, 3 equals derivative of y dy dx. Now this one has two dy dx's, but they're not on the same side of the equal sign. So the first step is going to be to move all of this over here. So we're going to subtract all that over. Again, I think that's the easiest way to do that. Be lazy with that, because the more times you copy, the more likely it is you'll make a mistake, because we're all human. Yes. As long as your answer is right, yes. Also, anything, because the exam is timed, I just thought of this, so I'm going to say it. Don't try to erase anything, because that takes time. You can do what's called a strikeout. If you just put a line through something, they will not read it. So you can use a strikeout. Okay. Now we're going to factor. So we're going to factor dy dx out of this. It's a greatest common factor. This is kind of tricky. 1, good, minus 5e to the y. And then your last step is to divide all of that over. Good, your algebra skills are excellent, guys. We don't have to worry about that at all. It's always frustrating when I have to stop teaching calculus and start teaching algebra, but you guys have got that. So. Yeah, when you divide, take 2. When you divide anything by itself, you get 1. That's tricky. All right. Derivative of x to the 4th. 4x cubed plus. This would be 10 times 1 over y. Are you guys comfortable with me just writing 10 over y? The 10 is sort of just there. The derivative is 1 over y, but the 10 is just kind of there. And then we have to chain on dy dx. Perfect. Plus 2y dy dx equals 0. Looks like just gobbledygook at that point. Such a mess. I do like this topic though. All right, algebra time. What are we gonna do first? What are we gonna move? Yeah, subtract over the 4x cubed. And then we're gonna factor out dy dx. That would leave you with 10 over y plus 2y. And then your last step is to divide that over. It was cool. We ended up with a fraction in a fraction. So I don't want to do anything to that. I'm not going to simplify that down. We have a 10 over y within this fraction. It's okay. I'm not messing with that.
If we were to simplify, like, would it simplify?
In multiple choice, they probably would. So if you're interested, I'll show you. What you would do is multiply the numerator by a y and multiply the denominator by a y in order to cancel, to divide that out. So you'd have negative 4x cubed y. And on the denominator, when you distribute it through, what would you get for this first part? Just 10 plus 2y squared. So it would look like that. I feel like, though, if you made it to this step, you would probably be able to look at your 4 choices and almost through instinct be like, okay, it's that one. Do you know what I'm saying? Like, if you get close enough to an answer, you can, like, feel your way through the last step, I think. All right, what on earth does this mean? Yeah, second derivative. Is that what you guys called them, double derivatives? Yeah, okay. I had a class one year that called them prime, and I just went with it. So whatever you want, yeah, double prime, double derivative. Second derivative is the official way we're going to say that. All right. So first things first, get your first derivative. It'll be 3y squared dy dx equals 2x. Cool. And then you're going to divide over the 3y squared. What's that? It's the second derivative.
So we take it
So
out.
we have to do it again.
So we're going to do it again. So since this is a fraction, what rule do we need?
Quotient.
Perfect. How does quotient rule start?
First, the second.
The second, the denominator. Yeah, the second thing. If you know where to start it, you will probably get the rest of it if you can like get the ball rolling. All right. Denominator, derivative of the numerator, 2, minus. Oh, if you're writing with pen, don't write this next thing because I'm going to have us all erase something, okay? If you're writing with pencil, stick with me, we'll just erase, right? Minus the numerator, derivative of the denominator would be 6y dy dx, perfect, over the denominator squared. So here's what you have to do.
So can you just make it the fourth?
You can make it 9y to the 4th. Yes. Sorry, I didn't hear the 9. But yes, you can write that. Here, actually, let's go ahead and do that. I'm going to do 3 squared is 9. Y squared squared is y to the 4th. That looks cleaner, so I like that better. You have to erase dy dx and replace it with what dy dx equals, which is, if you look back, what is dy dx? 2x over 3y squared. I'm not going to work the whole way through this one, but if you are interested, if they were going to simplify this down so you don't have a fraction in a fraction, you would multiply the numerator and the denominator by 3y squared, and you would distribute, and it would divide these out, and you would keep going. That's what you would do there, but I'm not super concerned about that. That's algebra, not calculus. Pep talk on related rates. They are word problems, and so it ends up being a more difficult topic for most people just because of that. You guys have done really well with the stuff from last year, though, so I have full confidence that you're all going to be just fine. What I love about related rates is we're going to sit down and like work out these math problems with like pencil and paper, but what's really cool is your brain does this automatically in real life without you even being aware of it. For example, if you are driving down the road, or if you are a person that doesn't drive, pretend you're in, the grocery store and you're pushing your cart, okay? You have motion. Someone else is coming from this direction in the car or with their grocery cart. They also have motion. You are moving at a certain velocity. They are moving at a certain velocity. You are moving in a certain direction. They are moving in a certain direction. It's how your rates are related to each other. Your brain will automatically speed you up or slow you down or change your direction to avoid a collision without you even being aware of it. Do you know what I'm saying? Like, your brain does related rates already. So, but this is my pep talk. You are programmed to be good at this already. Okay? So even though it will seem a little overwhelming, your brain is already made to handle this. That's my pep talk, okay? Okay. So, well, that's all I got. You're on your own after that was my pep talk. So you're on your own if that didn't do it for you, all right? So step 1, draw a picture if necessary. I'd say most of the time it's necessary. Occasionally there will be problems where you don't really need a picture, but most of the time you'll draw one. List out your given information and what you're missing. I call that the question mark value. I usually label whether it should turn out positive or negative so we can check if our answer is right. You're going to write an equation that shows the relationship between the variables. Okay, sometimes that's given, sometimes you have to come up with it, and you're going to take the derivative. Now here's where this piggybacks off of what we just did with implicit differentiation. You know how we did dy dx, and it was only for y? It was y in terms of x. Now it's every single variable, and they are all with respect to time. So say that louder. Every single variable is going to be dt. dx dt, dy dt, dz dt, dv dt, whatever, dA dt if you're talking about area. Every single variable is going to be dt. All of them, okay, with respect to time. And then you plug and chug. After that, there's no more calculus. It's all algebra. And if they want units, put in units, all right? I have videos that go with these. So we're going to go to, oh, please open. All right. Oh, I think I need to actually share my screen for that to show up on the video. So hold on a second. Let me, because I did have one person that's probably going to watch this from home. So let me share my screen. Well, you know what? Yes. And you have the option if you are like, hey, I zoned out, I got tired, it was the end of class, I need to see it again. You know, here we go. So look it. I need for you to watch because this is going to be the problem that we're going to do. Okay? You all see this? So a ladder is leaning against a wall. And look, it starts falling. Do you see how there's motion? And then just like you realize it gets back up again. Okay? So let me pause this and we'll read through. I'll read it to you. Okay? So it says a 6-meter ladder. Now, I know that the ladder is moving, but is the length of the ladder changing? No. Okay, that is constant. So that's 6-meter ladder. The bottom of it, so this X part, see how it's X of t, respect to time, is being pushed or pulled, whatever. It's just moving at a rate of a 0.5 meter per second. How fast, that's our question mark, is the top of the ladder sliding down? So that's our Y dimension. When it reaches 5 meters, and then they put 3 meters in one. We're only going to do the problem once, so we're going to do the 5 meters. They have to stay at 5 meters because if everything's moving, you have to pause it at a particular moment. You can't find the answer for all time. This is not everything everywhere all at once. Okay, you have to talk about one particular moment. Do you get what I'm saying? Okay, so let's go back. I'm going to stop sharing. How do I stop sharing? I want to get out of this. Yeah, let me come back over here. I found it. See, I figured it out. Okay. What kind of shape was our picture? What kind of triangle? Okay, we're going to draw a right triangle. The ladder was 6 meters. It's not changing. So you can call that 6, but do not put any values in your picture that are not constant. Okay? This dimension was X, this dimension was Y. They're both changing, so you have to give them a variable because they are varying. The 6 is constant. Now they said the base of the ladder is getting pulled out at 0.5 meter per second. We would label that as dx dt. Now, is it a positive half or a negative half? Well, what's happening to this distance? Is it getting bigger or smaller? It's getting bigger as it falls, so that's a positive 0.5 meter per second. Our question mark was how fast is the top of the ladder sliding down? So what's our question mark value? dy dt is our question mark, and should it come out to be positive or negative? Good, this amount is shrinking, it's getting smaller, so that should come out to be negative. I always write myself a note so that if I don't get a negative result, I can be like, whoops, okay? Now you have to pause at a certain moment. It said when the top of the ladder is 5 meters up. So that's when y equals 5 meters. Now we have to write an equation. You need a relationship between these 3 sides. It wasn't given, so you have to come up with one. What you got? Perfect. X squared plus y squared equals 6 squared. Now your derivative. Derivative of x squared. 2x dx dt. Perfect. Plus 2y dy dt. And this is a little tricky. It's going to equal? Perfect. 6 squared is 36. That's a constant. That's 0. What we're saying is the rate of change of the ladder is nothing because it's not changing. Okay? Now we're going to plug everything in. What is x? Do we have that in our list over there? No. Okay. We'll just keep on going. We'll come back to that. Do we have dx dt? What is that? 1/2. Good. Plus 2y. Do we have y? 5. Good. And then dy dt is what we're looking for, so I'm going to just leave that in there. Now, if you're missing something, and these are very important words, so listen to this. You go back to the original equation, the original relationship, and you plug in what you've got and look for what you're missing. So this is going to be like a margin problem. I'm going to go back to this original relationship right here and plug in what I've got and look for x. So it's going to be x squared. This is just an off to the side problem. X squared plus 5, and can I go ahead and write 25? We're all there? Okay. Equals 36. So you would subtract that, what is that, 11? So x is square root of 11, whatever that is. So I'm gonna put that right here. And now we're gonna solve for dy dt. And hope that we get a negative answer. All right, this 2 and this 1/2 will cancel. What would we start doing to get dy dt alone? This is our algebra here. Yeah, we're gonna subtract this square root of 11 over, so it'll be negative square root of 11.
Wait, I was 2 and 1/2 cancel.
Oh,
Kind of for the same reason that like 3 1/3 would cancel and 5 1/5 would cancel. 2 divided by 2 is 1.
Oh, okay, all right.
Okay, thank you. So we'll subtract over the square root of 11. So now it's negative square root of 11, which we want a negative answer. And then you would divide by, good, why 10? 2 times 5. Did we get a negative answer?
Yeah.
Go us, we're geniuses. Last thing is units.
Oh, millions per second.
Perfect. Do not make up units. They will be in the problem.